Hello, welcome back to our tutorial series, and this time we are going to talk about a charging and discharging of a capacitor. So let me write this is charging or discharging in a capacitor. So we know that let's say you have a capacitor right over here, it's a C, and you have a voltage source named as Vs, and it has some internal impedance or resistance R, and then it is connected to this capacitor. Here it is your ground or negative terminal or reference point. So the question here is, when you apply a voltage source to a capacitor, this voltage charges this capacitor with the polarity as shown in the figure. Okay. And if you disconnect this voltage source, then the capacitor will find a path to discharge the charge from its plate. So there is an equation that actually defines the charging and discharging of a capacitor. So for example, the voltage across the capacitor, this is called as VC. So this is the voltage that will be developed across the capacitor, and it is related to or is given by this equation Vs in bracket 1 minus e to the power minus t over tau and bracket close. So this is the general relationship or an equation that describes a charging curve of a capacitor. So we can say that where Vc is the voltage across the capacitor at any instant in time. At any instant in time t. Then we will say Vs is obviously this voltage source that is charging the RC circuit, that is the voltage source. Charging the capacitor. Now there is one more term, t, which is a time. It is given in seconds, and the more important parameter is tau, which is the product of R and this value C, that is called as time constant for charging and discharging these capacitors. So if we are asked to plot a graph or is essentially plotting this equation, so how will we do so? So let me just do that for you. So here we will do that. On the y-axis, you will have a percentage charge of the capacitor. That how much is the capacitor charged with respect to the number of time constant, that is tau. So let's say this is the percentage charge, and on the x-axis you have tau, which is your product of RC, okay, and that is the time constant. So you say that tau equal to 1, tau equal to 2, and tau equal to 3, and so on, tau equal to 7, something like this. So it is 1 RC, this is 2 RC, this is 3 times the RC, and so on. Okay, so what you see here, you start with the 0% of charge. The capacitor is 0% charged, and then you have a 10%, say 20%, 30%, 40%, 50%, up to, let's say, a 90%, right? That's how you will see that. And the equation that I just wrote right here, this equation shows the exponential relationship between the voltage and the percentage charge and the charging of the capacitor and the tau, which is a time constant. So essentially we are plotting the voltage across the capacitor. This is also called as VC. And you will have a curve like this. For example, let me draw with a pen here. And this is the behavior. You see that. So somewhere here at the, let's say the 60.63.2. So you will say that at this point, which is 63.2% charged, and the capacitor is charged to 63.2% of its final value at t equal to tau. That is the first tau, that is the 1 times the tau equal to 1 hours. And when the charging of the capacitor reaches, which is this point, to 99.3%, we say that this happens at t equal to 5 times tau. So this is the general rule that you need to remember. Now, what is the value of R and C? You can say that R equal to any value that you have in a circuit, let's say a 1 kilo ohm, and the capacitance is 1 microfarad. So your tau will be 1 into 10 to the power 3 into 1 into 10 to the power minus 6, which is about 1 into 10 to the power minus 3 second. Okay. So you will have like 1 millisecond to charge 63% on the capacitor, and at 5 millisecond, because 5 times the RC, you will have your capacitor fully charged up to 99.3%. So it's just like you are charging a battery with a voltage source. And this is the equation. This is how the equation can be plotted. Okay, and when it charges to 99.3% of its value, we say that the capacitor is fully charged. With that said, what about discussing the discharging of a capacitor? So let us say we are now discussing discharging of a capacitor, So there is obviously an equation to represent this behavior also, and we are going to see that in a moment. So the equation for discharging the RC circuit, again, let's say you have a resistor here, and then you have a capacitor here, R, C, and you have a switch right here, and you have this voltage source VI or VS, or let's say yeah, you say that this is your voltage source VS, and that's it. This is how your connection. So at time t equal to 0, you open this switch, and the capacitor will find the path to discharge this capacitor. Now we want to write the expression. So initial charge, whatever the charge on that capacitor, which will be represented by this voltage VC, will be written as VI, that is the voltage across the capacitor, VI, in bracket e to the power minus t over tau, and bracket close. So this equation describes the discharging curve of your capacitor. So your VC is the voltage across the capacitor at any instant in time t. So this is voltage across this capacitor at any instant in time t. What is Vi? This is the initial voltage of the capacitor at time t equal to 0. So at time t equal to 0, you open the switch. So whatever the voltage you had on the top of the capacitor plate, across the capacitor plate, that is your Vi, okay, of the capacitor at t equal to 0 second. Then t is the time in seconds, and you will say the tau is again the RC time constant that is responsible for charging and the discharging of the capacitor. So how about I now draw the curve for describing the the discharging behavior of the capacitor. So here it is. You again have this voltage VC, which is basically a percentage charged of the capacitor. So initially we are assuming the capacitor is fully charged by explaining, because we have seen how capacitor got charged, and we say that now the capacitor is charged to its full value, 99.6% that we saw before. Okay, so before that, let me write the pointers here. You have 0, and this is 0. Then you have like 20, 40, 60, 80, and then you have like 90% somewhere here. And then this is your 100% right here. And here we say that you have a time constant 1, 2, 3, 4, and let's say 5. And this is your tau equal to RC. So this is the number of time constant, and this is a percentage charge. So we'll draw that, the discharging curve. So again, as you can see, this is an exponential relationship right here. So it is exponentially decreasing, unlike the exponential increase in the charging curve. So you say that it is 99.6% somewhere from here, and then it is discharging like this. Okay, and essentially it goes to 0, but it's not drawn properly. So let me draw it well. So we'll say that at 5 time constant, it should reach to 0. So we'll say that somewhere here, not here. Oh, we have to, let's undo the behavior. Somewhere here, like at 36 point something. So this is here. So here we'll see that this axis actually is wrong. So let me draw it well. This axis is not properly done. So let us draw this properly. The points. Here it is 0. Then you have like 10, 20, 30, 40, 50, 60, 70, 80, 90, and you have like 100. So then you have to take rid of this, get rid of this also. Okay, and then you again come with your black curve. This is how you do that. And now you draw the curve. It is like you start from here and then you end like here. Okay. Well, so now here, for example, at this point somewhere, you say that your capacitor is discharged to 36.8% at T equal to tau is equal to RC, that is your time, T equal to RC, 1 tau. And at this point somewhere you say that capacitor is discharged to 0.7%, which you can say it is fully discharged at T equal to 5 times tau. So when you have 5 times the RC time constant, you will have the discharging curve. Okay, so given the values of R equal to, let's say, 1 kilo ohm and C is equal to 1 microfarad. So at tau is equal to 1 millisecond, your discharging will be about 36.8%, just like your cell phone battery, for example. At tau equal to 5 milliseconds, you say that this is 36.8%, and you say that this is about 0.7%, the battery discharge. So capacitor is just a battery. So I hope you enjoyed this video by understanding the charging and discharging behavior of your capacitor. Remember, C is equal to Q over V. So capacitance is the charge upon voltage, where V is the voltage across the capacitor, charge is the quantity that it holds across its two plates, and C is the capacitance. So do like this video, comment on it and share it with others for a wider reach. Wish you happy learning. Stay tuned.